guys, welcome back. It's me Badri. So here we are with a new topic called matter in our surroundings, which is a chemistry chapter and it's a chapter 1. So let's go. So this lesson is quite easy. At our surroundings, we see a large number of things with different shape, size, and texture. Everything. If you take you will see that it has a quite definite shape, definite boundary, a definite weight, and a proper volume. So, for example, an apple. The air we breathe, the water we drink, the bed in which we sleep, everything is matter. Yeah. Everything that occupies space and have a mass, in other words, they have both mass and volume, is called as matter. We have already studied in our lower class. So in matter there are 3 types of states, which are liquid, gas, and solid. For example, if water is most familiar in a liquid state, and when it's burnt it becomes a vapor, and when it's freeze it's ice. So like that. So let's go. So early Indian philosophers classified matter in 5 types: Panch Tattva, that is air, earth, sky, fire, and water. According to them, everything, non-living thing and living thing, were made up of matter. Ancient Greek philosophers had similar classification, but it was little different. Number 1, matter is made up of particles. So if we take, this is an object which is a solid. This pencil is solid, which has more tiny particles inside this, which is beyond our imagination. So like there are different type of. Take a beaker and take some potassium permanganate, and it's basically some small crystals. When you take 23 crystals and dissolve in around 50 ml or 100 ml water, you may see the change in the color to a dark pink or dark purple. When you mix it, when you take 5 ml of the 100 ml or the 50 ml and pour it to another beakers continuously, you can see the change in the color slowly, but you can see that there are more millions of crystals inside one small crystal. So you can see the one crystal is enough for giving color to almost 1000 ml liter, 1000 liter. So as we told, I conclude that millions of tiny particles in just one crystal. So on which keep on dividing them into smaller particles, more smaller particles. This same activity can even be done with a 2 ml Dettol. Like you take a Dettol and mix it with water and you repeat it again and again, but you can feel the smell of the diluted solution. Okay, and particles of one matter. Okay, how does, like if you take a salt or sugar or anything, okay, you take a glass of water, you mix it in water, you know that it gets dissolved faster. And you know why it gets dissolved? Because the particles in the sugar or salt get into the space between the particles of water. So let me show live experiment. So guys, so I have got a beaker, a plastic beaker, in where I have filled 3/4 of the water of the beaker. So you can see that I have some sugar. So let me take some. So sugar has some, like they are still so small, like a tiny sand particle. So they have around millions and millions of other tiny particles. So just guess what is this? What type of matter it is? Solid, liquid, or gas? Yeah, you're correct. It's solid. So let's mix it. So let's take the beaker. So let's dissolve it. So when you put it, so I have put it in, you can see the crystals, like the particles of sugar down. So it's going to slowly mix it. So if you mix it, it will slowly dissolve. Until that, I will say one thing. It's because of the tiny particles which are present in the water. Okay, the water has some tiny particles in them, right, which dissolves with the particles in the sugar. the particles in the sugar go inside the space between the particles of the water, and hence they dissolve. Okay, you know that water has more space compared than a solid, so they easily get dissolved, and that's why. So now we can see that only little bit of crystals are there, so our water is completely dissolved. So you can see it. Okay, can you find any change in the color? No, not a big difference. So as we told, that's what particle of matter are continuously moving. Okay, we possess that we call particles. Okay, as like I have this, right? Yeah, as we increase the temperature of this water, due to the kinetic energy, the particles also increase. So there is more space in the water, so it's easy for it to dissolve while we eat it. Okay, now what is diffusion? Okay, particles of matter intermix on their own with the particles of other matter is called as diffusion. Yeah, as we looked at the salt or sugar which we dissolved in the water, the the particles in the sugar get into the space between the particle of water. That is called diffusion, and diffusion can be in any type. Yeah. Okay, let me ask a small quiz. If you know the answer, you can comment it, or I'll say it now. So which of the following are matter? Chair, air, smell, eight, almonds, thought, cold, lemon, water, smell of perfume. So which can it be? So chair, smell, and almonds and thought. In this four, which is matter? Yeah, chair is absolutely matter because it has a definite shape and it has a definite border and a definite boundary and a definite volume. So chair is a solid. And is air a solid? No, air is not a solid. It's actually a gas because air spread from one place to another. It has no big mass and it has no definite shape, and that's why it's called as gas. And smell is same because it's like gas. It is not. And if you take almonds, which are strong and as a definite shape, it is a solid. So from this we can understand that. Okay, as I told you before, matter exists in three following, that is liquid, gas and solid. Okay, let's take the greatest example of all time, the water. So the water which we have is liquid, and when I freeze this, it becomes a type of ice. Yeah, you know ice. And if I take the water and keep it in a kettle and boil it, a type of steam come in it, right? What is it called? It's called vapor. Okay, and the vapor like mixed with the air and splits, that is a form of gas. So that's the best example. Okay, the best example of solid is that like the characteristics of solid is that they have a definite shape, definite boundary and a proper volume, mass or anything in your words. So liquids have no fixed volume. Okay, now let's come to the liquid. As we saw about solid, now let's go into the liquid, move further. So liquids, they are not like solid, they don't have a fixed volume. Yeah, I mean they do not have a fixed shape, but they have a fixed volume. Yeah, if you fill the water in this container, before this I took this water, it was in another pot. From a tumbler, I took the water from the pot and put in this container, I mean the beaker. So it fills up the shape of the container. So water is not rigid or rugged, but it is a fluid because it can flow. Anything in science which have the capacity to flow is called as fluid. Okay, as we know that solid can dissolve in water, yeah, some solids like ice can dissolve in water or sugar can, and liquid can dissolve in liquid. Yeah, it's obviously liquid in liquid only. Okay, so you just like stir it get combined. If I took a rose water and a normal water, when I pour that, it actually changes the color, nothing else. But can we like dissolve gas in water? How does gas form from the water, right? So how can we like dissolve gas inside water? Huh? So if you have that doubt, you can think like how do fish like breathe inside the water? We know that fish and other aquatic animals, everything in the world, any animal, any creature needs air to breathe. So what do they do in water? How do they breathe? They cannot even come up. So there is some amount of oxygen or carbon dioxide, especially in water, which are in a dissolved form or like the diffusion form, where it is more easier for the fish to breathe in it. So what if the oxygen and carbon dioxide is not there, it's not dissolved in the water? The fish cannot live, the aquatic forms cannot be there, and nothing can be there. So as we saw that aquatic animals can breathe underwater due to the presence of dissolved in oxygen in water, thus we may conclude that soil, liquids and gases, anything can dissolve in water. So we have observed that gases are highly compressible as compared to soils and solid and liquid. So we know that solid, okay, you can see the picture over here where the solid is very combined to each other, the small dot, there is a really less space between them. And next is water, where water frames little freely and has a little bit space, and where gas is totally free and the particles move more faster and have more space. So that's why we can make them into more tight, like pressing them. So that's why like we have observed that LPG, which is liquefied petroleum gas, which has been used in our gas stoves or many places, LPG. So LPG gas is more efficient nowadays, but now we know about the CNG, compressed natural gas, which is now more efficient and used in more vehicles for and more eco-friendly society. So I think so most of them are using nowadays CNG, and most of the vehicles run in CNG. So even live that during the pandemic time, lots of oxygen cylinder were needed. So the cylinders have oxygen in them, but a larger volume of gas can be stored in a small cylinder. So why? Because you can easily like carry it or take it anywhere and use it in anywhere, and but the weight is more, yeah, than the cylinder. Okay, let's go like about you. Okay, your mother makes some food in your house. Okay, she makes soup, mushroom soup with with a mushroom soup. Okay, and she is making it, and you finish your playing outside or studying, and you go into the kitchen and you see her like making something. But when you reach the door of the kitchen, you may like feel the smell, or just behind it, like while you're walking near the kitchen itself, you can get the smell of the, and you can even identify what food it is. Why? How do you like identify the food, the smell of the food? So basically the smell, okay, which expands. Okay, we know that gas have more space, the particles have more space compared to anything. Okay, so like when the gas, okay, so the aroma of the food which comes in the vapor form like spreads in the gas, get into the space between the gas, and it travels more faster because it has more particles and a really large number of space in gas. That's why the aroma of the food reaches us really faster when we enter the kitchen or farther away. So that's why. So like I have a doubt, even if you like smell the food, how do you identify which food it is? Yeah, I know that most of you will know that it's because of some particles, okay, like spices and anything which vaporizes, like combine and vaporize, which comes to your nose. You know the smell of the food, okay, so you can understand it. So, and it's just a general one which I told you now. Okay, what is melting point and boiling point? A stage is reached where the soil melts and converts it into a liquid. Okay, the minimum temperature at which a solid melts to become a liquid at the atmospheric pressure. What is atmospheric pressure? The pressure around you in the atmosphere. It is called as atmospheric pressure. A blanket of air is called as atmospheric pressure. Okay, so the minimum temperature at which a solid melts to become a liquid at the atmospheric pressure, it is called its melting point. So even if I take this pencil, it has a specific melting point. If I keep a fire near it, it will melt slowly, but it has a specific melting point where it burns faster and totally. That is called as melting point. The melting point of a solid is an indication of the strength of the force of attraction between its particles. Okay, the melting point of ice. Okay, now I freeze this water and bring it outside and I keep it in a kettle or somewhere in a burner. Okay, you keep the ice in a beaker and melt it. Okay, what's the melting point of ice? The melting point of ice is 273.15 K. The process of melting, that is change of solid state into liquid state, is also known as fusion. Okay, the melting, in easy words, melting of solid to liquid is known as fusion. It's very easy to understand. Okay, so till this we end the chapter 1's part 1, and in the next video you will see the part 2. Thank you.